So it's going to be 0 to 1 here. Any question on that? Okay, now when you simplify this guy right now, okay, so 0 to 1, x plus 2, and this is going to be 6, maybe 1 over 6 here, then the s. Look at that. Okay, where you plug in, this is 4 plus 2, 6, so 1 over 6 out, then you just go for D. That's super cool. Now, you've been doing all this in high school, but, in high school, you're just doing math. But right now, you can see, what led us to that. So by the time you do that, you actually finally, okay, now, S plus 2, 1 over 6 is what you are seeing here, right? Now, if I now want to do the integration, you see what I'm doing? From 0 to 1, because they mentioned the probability of S less or equal to 1. What is a random variable? Here is X. I already have information about Y. Y is no longer a random variable. Now, then by the time you try to do that, you get 5 over 12 for that. Okay. Now, I want to go to another example, and I need you to pay attention. This example is very, very crucial, okay? And I need you to pay attention to this. Now, let X and Y denote the proportion of two different chemicals in a sample mixture of chemicals used as insecticide. Suppose X and Y have a joint probability density function, but let me tell you this. Here, the probability density function, the joint, is a constant. You can see equal to 2. That's a constant. We can also have a constant function. Now, but there's something I need you to pay attention to in the state space. This is a special one. It's telling us S lie between 0 and 1, Y lie between 0 and 1, and addition of X and Y lie between 0 and 1. Don't forget, you want to make an insecticide. You want to actually, you're making these chemicals for insecticide, and you actually want to use a combination of X and Y. So adding X and Y, they should be less or equal to 100% as well. Now, the question I asked, find the marginal density function of X and Y. Then are X and Y independent? Then another question said, find the probability of X greater than half, given that Y equal to that. Please, I need you to pay attention. Now, look at the way I'm trying to find my f of X right now. Finding my f of X is still going to be the same thing. F of xy integrating with respect to y. Okay. Now, if I'm integrating with respect to that, that's why you see to the y. But your state space, please pay attention. What you're going to use here. You have to put into consideration s plus y lie between 0 and 1. If I'm focusing on y here, okay, focusing on y here is going to be 1 minus x. Okay, do you see that? 0 to 1. That's why I have 0 to 1 minus x. Okay, I'm only going to use 0 to 1 minus x if I want to figure out a marginal. Okay, but if I want to use that f of x later, maybe to find the mean, I'm still going to use between 0 and 1. Okay, do the same thing here, do the same thing here. Okay, do the same thing at the other hand. Okay, we got this now. Now we got f of x and f of y, and to be able to check whether they are independent, what we just need to do, when we multiply this marginal, do they give us the joint? Okay, if we what is the marginal now? What do we get for the f of x? What do you get for the f of y? We got this guy for f of x. We got this guy for f of y. If we multiply this guy by this guy, does it give f of xy equal to 2? Obviously, no. If it doesn't give that, then your conclusion is they are not independent. That's what I'm doing here. If they are not independent, then it means they depend. That's what it means. Not independent. Negative, negative. Of course, that means they depend. Okay, now to answer the last question. Okay, the last question talk about find the probability of x greater than half, given that y equal to 1 over 4. Now here, you need a function of x given y. You need a function of x given y. Now, if you take a look at what I'm doing, that was y. Here, take a look at this. I'm trying to tell the world, if I want to get the probability of x greater than half giving y equal to 1 over 4, I need to first derive a function of s given y. And after deriving a function of s given y, then I'm actually going to, whenever I see y, I'm going to plug in 1 over 4. But let me tell you this. Do you know, if you don't get your f of s right, or you don't get your f of y right, you're actually going to make a mistake when you're figuring out the f of s given y. Because the f of s given y, okay, the f of s given y is the ratio of this to this. The moment you actually get this wrong, any of this wrong, the OT is going to be messed up. That's why you got to be careful, okay? Okay, now, right now, doing that, then I'm plugging 1 over 4, then I'm going to integrate because it said greater than half. Ooh, greater than half. That means it's going to start from half to the upper bound of x. What was the upper bound of x? This was 1. That was why you see 1 to 1. And finally, we got that. Okay, because of my time, I'm going to go into today's material. Is there any question? Okay, so I'm going to go into today's material. And place we actually going to go more mathematical, but not going to be theoretical. This is going to be kind of easy. I can trust you that. Okay, now I want to welcome you to today's material, expectation and variance of jointly distributed random variable. Let me tell you this. The essence of why we need to understand the probability function is just for us to be able to obtain basic statistics like getting the mean and getting the variance and so on like that. Now, we've done that when we're working with x and y separately. How do we now get expectation, okay, and variance when we are focusing on more than one variable that are distributed? That is actually the focus today. Okay, so that is the focus today. Now, please, I need you to pay attention. Okay, I need you to pay attention. Now, this is like what I've walked you through today. Trying to revisit your knowledge of situation where I'm dealing with S and Y, and they are both discrete, and of course, the probability of the joint occurrence of them is actually going to be this guy here, and of course, non-negativity, the probability of X and Y has to be greater or equal to 0, and when I sum them, of course, over the state space starts to be 1. And of course, what I'm actually doing here is the marginal probability for S. And what I'm doing here, the marginal probability for Y. I just wanted to understand that. Of course, I also have that on the board. But you know what? When I have a function of X and Y, how do I find the mean? Take a look at this now. Okay? How do I find the mean? The mean is the same as the expected value. Okay, now I want to find the mean of a function, is x and y. I'm not just finding the mean of x. I'm not just finding the mean of y, but I'm finding the mean of the combination of x and y. Okay, now I need you to pay attention to this right now. Take a look at this guy now. Okay, you're going to see the focus. Look at that. This guy mean of a function of x and y. Mean of a function of x and y. A function of x and y could be whatever. This particular function here is not a probability function. Does that make sense? This is not a probability function. Okay? Now, the x and y itself is going to have a probability function, which is this. The ps comma y is a probability function that we call the joint. Okay? But the h, x, y is the random variable. H, we can have a situation where S is a random variable, Y is a random variable. The combination of them can also be a random variable. That's what I mean. Okay, and when I want to find the expectation of that, I'm actually going to use two summation as against 1. Okay, now and I have to tell the world, okay, I'm actually focusing on risk squared, So because X is in real number, Y also in real number, I'm quickly going to go into application. Please pay attention. I'm seeing a lot of final here, a lot of final. Like I said, all of this is not going to be in the midterm two. I've already sent you the midterm two practice question, but I'm seeing a lot of final question here. So please pay attention. You don't understand? Just ask question. Now, do you know you can be given a table whenever you got a table this way? Whenever you have a table where S is cost listed with Y, of course, that will be it's telling you S is discrete and Y is discrete. Here, Y has 3 levels, 0, 1, 2, and X has 6 levels. Take a look at that. Now, the very first question asks, what is the probability of S equal to Y? Okay, you want to identify where X and Y are the same. Okay, where X and Y are the same is where you're going to have 0, 0, 1, 1, 2, 2. I don't know. Do you understand that? Can we have